Okay, so this is the last question we look at, trigonometry, 2014. So an activity center has a zip line which is BD. So your zip line is running along here and runs vertically between two poles, A and B and CD. So this is one pole over here, the other one over here. It says the point E is on the ground directly below the zip line, and then it gives you some details. So the first question asks us to find the distance ED. So we want to find from here to here. Mark that as x. This is simple enough. It's a right angle triangle, theorem of Pythagoras. So when you're doing this, it's going to be x squared, which is the hypotenuse, because it is opposite the right angle there. X squared is equal to 1.95 squared plus 10 squared. And then when you go work out that at the end, you end up with 10.2 meters. So x here now we can change to 10.2 meters. Next question is asking us to find the angle AEB. So let's go back to look at the question. AEB. So AEB is AEB. So it's in here. That angle there is AEB. So let's see if we can figure this out. So taking this triangle here, we've got a 12 on the bottom and we've got a 14 along the top, and then we're looking for the sides. So we have a triangle that looks like this. So we have 12 here, we have 14 here, and then we have an angle that we don't know. So anytime we have an angle we don't know, we can use sine, cos, or tan. This is the hypotenuse, and this is the adjacent. So adjacent and hypotenuse is cos. So we've got the cos of x is equal to the adjacent over the hypotenuse, which is 12 over 14. Adjacent over hypotenuse. And then we can just work out x. So x then is going to be equal to the inverse cos of 12 over 14. So that's going to give you a value of 31 degrees. Part 2 then, or part B, part 1 says find angle DEB. Given that CED is equal to 11 degrees. So again, going back to the question, we want to find DEB and CED is 11. So let's put that in. CED is 11. So starting at C, then moving to E, then moving to D. So CED is 11 degrees. So this here is 11 degrees. We can also get rid of this shading here, and we can put in the details that we've just figured out. So the last one we figured out was AEB was 31 degrees. So this is 31 degrees. And the next question is asking us to find DEB. So start at D, go to E, and then go to B. So DEB is this angle in here. DEB. That's the one we want to find. And this one actually isn't too bad, because what we have is from here all the way around to here is 180 degrees. And we have 11 of it, we have 31 of it. So the bit in the middle is what's left out of 180 degrees. So back down to this, we say 180 degrees, and that's going to be minus the 11 degrees plus the 31 degrees. And that gives you a total of angle BEB, the measure of it, is equal then to 138 degrees. Hence or otherwise find the distance of DB. So we can pop this in as 138. So the next one is to find the length of the side DB. So where's DB? DB is the zip line. So this is what we've got to find. Again, I would probably redraw out that triangle to see what I've got. Let's go down here and let's start redrawing the triangle. I'll be back in a second with the triangle. Okay. Okay, so here's our diagram, copied down from above. So again, is it sine rule, is it cosine rule? It's not going to be sine rule because you need more than just the one angle. And this is all we've got. So we're going to be dealing with cosine rule. A squared equals b squared plus c squared minus 2bc, and then the cos of angle A. So if I'm going to be putting in the cos of angle A, that's going to be the cos of 138. That means my side A is the one opposite the angle. So that's going to be x. So I've got x squared equals, and then the other two sides, 14 squared plus 10.2 squared minus 14 by 10.2. Bit of a squash there. So you end up with x squared then is equal to, and you work it all out, 512.28216. Leave that number long because you're going to get the square root of it now, 512.28216. So our answer is accurate. So we end up with x then is equal to 22.6336, and then round it to one decimal place is going to give you 22.6 meters.